For this project, we must design a fixture to hold the bottle opener operation number 1 securely in order to perform operation number 2 to finish the opener. This design must interface with a Haas EC400 horizontal mill with a pallet pool and a Tombstone City tombstone. The fixture will be indicated into the machine axes, locate the part off qualified datums, and be capable of producing one finished part per cycle. We used the given stock size and SOLIDWORKS models of the stock parts to begin the design of the fixture plate. First, we reduced the size of the plate to 5.5 inches wide to minimize stock price and to keep the fixture as compact as possible. We included slots for the T-nuts to mount the fixture to the tombstone with sufficient depth to hide the bolt heads. A 0.481 inch wide slot secures the locating rail and runs out to the edge of the fixture to allow for easier chip clearing. The depth allows for clearance between the rail and the lowest tool path, and secures the rail and the fixture under clamping loads. Following Mighty Bite specifications for the clamp, we placed the mounting hole at the specified distance from the edge of the bottle opener blank. We recessed the clamp so that it also allows clearance for the lowest tool path. We ensured that the pocket goes slightly underneath the part blank to allow for the clamp to contact only the workpiece. The top surface of the fixture and clamp system limit 5 degrees of freedom, and the sixth is limited by a 1/4 inch dowel pin press-fitted into the fixture plate. We chose to locate the workpiece on the fixture on the inside of the bottle opener for ease of part insertion and removal. To ensure the fixture is set in the machine square to the x-axis, we machined an indicating band on the back of the plate for a test indicator to sweep. Since the workpiece blank is very thin, and the locating pin further clutters the space inside the bottle opener, we machined a 1-inch circular pocket for the machine to probe as the work coordinate system.
Using a 0.25-inch end mill, we calculated the maximum cutting force our fixture would experience was 78.09 pounds. Mighty Bite rates their clamps at 800 pounds, so one clamp should be more than enough to safely hold the blank. We also performed a finite element analysis of the blank under the 800-pound clamping force, and we simulated that the maximum deflection would be 0.0008 inches, which is effectively insignificant. We located the clamp on the thickest section of the part to ensure minimal deflection. Additionally, the maximum stress simulated was approximately 8,000 psi, while the yield strength of 6061 T6 aluminum is roughly 31,000 psi, so the design is safe in that regard too. Machining off the fixture plate begins by centering and securing the blank in the vise. Using the Z touch-off on the bottom of the jaws and XY webs on the edges of the blank, the G54 location is set. The program is then run, taking a total of 17.55 minutes. Firstly, we use a 3/8 flat end mill to contour the sides, indicating band, T-nut relief, and T-nut slot. The same tool is then used to bore the indicating hole and rough the rail pocket. The 1/4 inch flat end mill is then used to finish the rail pocket and clear the Mighty Bite relief pocket. The holes are all spot drilled and drilled. The pinhole is then reamed and the tapped holes are tapped. A 90-degree chamfer tool chamfers all sharp edges. Lastly, a 1/16 inch ball end mill is used to engrave the text. The CAD and CAM modeling are all done in SOLIDWORKS, with the HSM Works extension used for the CAM portion. A cost estimation was then completed using machining and engineering times. The total price to design and manufacture the fixture is $795.65. This consists of $637 in engineering time, $60 in materials, and $70 in shop time. The fixture design worked well to secure the bottle opener using only one Mighty Bite clamp. The parts came out with consistent quality. The fixture meets all our goals for ease of use and installation. Overall, we are happy with our fixture design and manufacturing.